Well, good afternoon, good morning, or good evening, depending upon where you are in this world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, your moderator for today's event, and I welcome you. We have a great event on tap, but before we get started, I just want to remind the audience that today's event is being recorded. So if you miss any or all of the webinar, just know you'll be able to access the webinar on demand. We'll be sending out a link after the event that will take you right to the webinar on demand. Okay, with that, we'll go ahead and get started with today's webinar. I welcome our panelists today.
Good morning, everyone, or good afternoon, depending on where you're watching this session from. I'm CMX Saragyan, the technical marketing for OpenShift, the Kubernetes platform at Red Hat. And I want to talk about how we can apply DevOps principles for hybrid applications in today's market where applications are built of several components. So if we look at how we traditionally used to have our applications, the principle was that we often deployed these components on some physical servers or virtual machines, and there were several components that were talking about it. So we might have an Oracle database that is running on an Oracle rack, and we have a Java application, Spring Boot or JBoss EAP or something else deployed on a virtual machine. We might have a cache on another virtual machine, maybe MQ server or something else, and they talk to each other. So if you look at an infrastructure perspective, it was quite homogeneous in sense because our compute paradigm was mostly virtual machines and physical servers. But if you fast forward to today, applications are combining several of these compute paradigms together to provide a single app, a single portfolio of app sometimes. So the industry has moved on from virtual machines toward containers, not to replace virtual machines and bare metal servers, but to complement them with workloads that can be deployed on containers, especially cloud native applications, because it's easier to deal with them. They're lighter, they're faster, more dense, and they're more portable across several environments. And on top of that, there are functions that are coming along with function as a service, AWS Lambda. We just had Knative announced from Google at Google Next, which provides the plumbing for different type of function as a service that will show up on container platforms. Azure and Google have their own, and there are other ones. And also there are a set of really innovative cloud services out there on Azure, AWS, and Google that people want to combine with that, or even possibly IBM. So there is Watson API, for example, if you want to do sentiment analysis or other type of AI related, or using AI services on Amazon or big data combined with your application. So applications today, from a compute perspective and the services that they use are a lot more complex than they used to be. They still have some part of it that are deployed on virtual machines, but there are other pieces of the application that are deployed in other forms, being containers, running on a container platform or running on a host itself, being a set of functions combined with this, and a set of cloud services, which provide a more complicated scenario for us if you're looking at an automation perspective, that from a DevOps perspective. You want to apply an end-to-end automation to this kind of application. Now we have to think more thoroughly how we can combine different automation aspects that we have across all different types of deployment and cloud models that are in the picture in today's applications. But what we have been doing in the infrastructure space a lot is using Ansible. So Ansible has been a great DevOps tool for everyone in the industry to be able to automate different aspects of the infrastructure. So if you want to create a virtual machine on Amazon, usually there are a set of modules for that within Ansible. You can declare what you want to create, run that, and that would automate creating those virtual machines on top of Amazon for you. It goes to other type of infrastructure provisioning as well. It could do network configuration or load balancer and other aspects of that. So it has been a really powerful tool for automating the infrastructure for us, especially when it comes to the virtual machine type of infrastructure. It's expanded to other types as well, but that's where it started really. The way it works is that you describe what you want to happen over your infrastructure. So maybe create a couple of hosts, configure the networking, open a port on the load balancer, and so on in a YAML file that we call Ansible playbooks. And you run that through Ansible. It gets some data, some configuration data from the configuration database, like where are your hosts, what are the IP addresses, what are the credentials, and so on. And it runs based on that declaration, that playbook. It runs those commands, those state on the target infrastructure that you have defined, and makes them look like the way you have described them in the playbook. So it has been a really convenient way for us to apply DevOps on top of our infrastructure, automate a lot of the tasks that we do on the infrastructure through these Ansible playbooks. To just give you an example of how an Ansible playbook looks like, you can see a simple YAML structure that is composed of a number of tasks, and a task is doing something specific. For example, this playbook is showing how to install and start an Apache HTTP server on a host that we have defined in our configuration database, where that web host is, and it finds it in that configuration database, and it starts going through each of the tasks on those hosts. It first installs HTTPD, then add some type of configuration and make sure that it is started. So it's quite simple and declarative. We define what we want, and Ansible can apply that on top of that infrastructure. We could combine that with some kind of CI/CD engine or Jenkins or Bamboo. That would be the one that runs the Ansible playbook on that infrastructure. There's also Ansible Tower that helps us to scale these playbooks and run them across larger infrastructure. So that is covering our infrastructural needs. But at the same time, containers have become the essential unit of compute for cloud-native applications. So any new application that is built and deployed today is generally built around containers and deployed in containers because they're very lightweight and portable. Portability is a huge factor in this. So if my application is packaged as a container, I can deploy it on my own laptop and then take the same one and deploy it on OpenStack, on a virtual machine on OpenStack, or maybe move it around the clouds on AWS or Azure or other ones. So I can take the same application, same packaging without rebuilding it, repackaging it. I can just take the same and move it around in a different environment. And plus that is a lot lighter. I can run a lot of them on the same host. I can use my resources a lot better. It makes it a lot easier to deal with different aspects of the application, configuration, and lifecycle management when we are packaging them as containers. And when we run a lot of containers, then we need some tool or controller to manage these containers for us, to deploy them on top of the host that we need. And Kubernetes, a project that was donated first by Google, came out of the Borg and Omega projects at Google. And they have taken all that learning, put it in a project called Kubernetes that came out a couple of years back, and now it has become the de facto standard for deploying containers. So what Kubernetes does essentially is that you describe what containers you have, how they should be deployed, how many of them, what kind of resources you want to dedicate to them, how they should be configured, possibly, and you send that to the Kubernetes master, which is the brain behind Kubernetes. So Kubernetes takes that YAML, that JSON, and applies that on top of the hosts that are dedicated to Kubernetes. So turns them into containers that are running on top of those hosts, and make sure they are configured the way that you describe them in that YAML file. To give you an example of Kubernetes YAML, you see on the slide, there is a definition of a deployment. So we're telling Kubernetes, declaring, describing for Kubernetes that deploy this container, and we refer to a specific container image. We're deploying Nginx, a specific version of it in this case, and we're saying create 3 containers out of this image, deploy them on top of those hosts that I've configured and given to you. And Kubernetes automates that whole process to go download the Nginx image from a registry that is defined for it, and then deploys it on top of those hosts and make sure it's running 3 instances at all time. It opens the port that we have defined for it. If one of them dies, it brings them up again. If something happens to them, it restarts them. So Kubernetes manages the life cycle of that image when they're deployed. It makes it really simple, all with this few lines of YAML file, that YAML that we have described for Kubernetes. The rest of it is automated through Kubernetes. So Kubernetes does a really great job of automating the life cycle of the container for us. We don't really need to do anything more than just building our images and describing what we need, and the rest of it Kubernetes takes care for us to deploy and manage it on top of those hosts. But if we combine these two technologies together, Ansible plus Kubernetes, it gives you a really powerful combination that not only we can cover our container automation needs, which is focused more on newer applications, cloud native applications that are built and packaged as containers, and Ansible that is really powerful for automating all aspects of infrastructure. Then we have a winning combination that we can deploy application and automate the process, the release and deployment process, regardless of what kind of compute unit they need. So my application might require some changes in the networking, in the switch and the load balancer, and at the same time it might have a database that needs to be deployed on a virtual machine. Some components of it is in the container. We have to create and update a couple of the functions that are running on AWS or maybe on-premise on our own data center, and we are combining with some kind of big data or some other cloud services that we have on Azure. So we can automate end-to-end this whole process if we combine Ansible and Kubernetes. And the way that would work is that we create a set of playbooks for Ansible. We run those to apply those changes or those provision, those services that we want through Ansible. And then we create a bunch of YAML files for Kubernetes and give it to Kubernetes as well to automate the deployment of those containers. So we have these two steps that we run, and it automates end-to-end everything for us. Fortunately, these two technologies have started collaborating a lot more than that, and it has made it a lot simpler to combine Ansible and Kubernetes together to provision services that are applications that are hybrid and combined of containers and other services. Automation Broker is an implementation of the Open Service Broker API, which combines Ansible and Kubernetes together. Open Service Broker API is a standard. It's a standard that a lot of vendors in the industry have come together and agreed on a contract how we can expose external services on top of Kubernetes-based platforms, so that whatever you build, you can move it around in different Kubernetes platforms. You're portable, your services across different Kubernetes distros. And specifically, Automation Broker it implements that API and allows you to run your Ansible playbooks directly through Kubernetes on Kubernetes. So you don't have to go outside and run your playbooks separately from Kubernetes resources and how you apply your resources on Kubernetes. You can create a package that is called APB, Ansible Playbook Bundles, and that includes those playbooks that you need for provisioning your application and those services. And Kubernetes is the one who deliver that APB to Kubernetes. When you say you, this is the administration, like the IT operation. They create these APBs because we're talking about infrastructure services and deliver it to Kubernetes. And Automation Broker is in charge of when a developer says, give me a database on AWS and combine it with this service and this other service on Azure and create this function as well, then Ansible Broker knows that it has to go pull down that APB from a place that it knows where it is and run through those playbooks and create those services and run through a couple of other declarative syntax or YAML files for Kubernetes to deploy those as well. So from a developer perspective that is deploying the application, they don't really need to care about if Ansible is doing something or Kubernetes is doing something or someone else. All they need to do is that they go to the service catalog of the Kubernetes. They can select a couple of services and deploy that, and as the Automation Broker take care of deploying some of those services through running playbooks on Kubernetes to provision those infrastructure services, and at the same time running a couple of other things to deploy the services on Kubernetes. I'm going to show you this in practice as well. We take a look at a demo of how this works in practice. So we have an application that I'm going to use in this demo. It's called Cool Store. It's an online store. We have a number of cool items that you're selling here. We have some PK shirts, some stickers, and so on. And if you look at how this application is deployed, this app is deployed as a a number of containers right now in a project called Cool Stove Dev. I'm using OpenShift in this demo. OpenShift is the Kubernetes, enterprise Kubernetes distro from Red Hat. It really simplifies it for us to set up Kubernetes and run our applications, build and run our application on top of Kubernetes. So I have two projects. One is Cool Store Dev, our development environment. There is a production environment. If you look at a development environment where I've been looking at an application, we have our application deployed, which is 3 containers right now. There is web UI, which is the web component of our application. This is the web, the interface of it, and it has a backend which is called catalog and a MySQL database that is running as a container in our development environment. So right now I have an application that is cloud native. All components of it are containers that are running on Kubernetes, on OpenShift within the dev project. But what we usually do is that, especially when it comes to databases, we generally want to use virtual machines because some performance aspect that are related, or replication or other requirements that some applications need. And for this specific application, we want to use DigitalOcean. DigitalOcean is a cloud provider for it's for different type of services like virtual machines and other services. We're going to use virtual machines today. If you look at the same application in production environment, we see that we already have our database deployed on DigitalOcean. So we don't have any catalog MySQL deployed as a container, and we have a provision service that is called DigitalOcean MySQL. I'm going to log into my DigitalOcean account as well. You see that my database is running. This is the production database. But how do we do this? How do we create these databases on a cloud provider? Speaking of hybrid application, we want to automate that aspect. So what we generally do is we create a bunch of playbooks. For example, we have a playbook for creating MySQL databases on DigitalOcean, as you can see on the screen on GitHub. It's a playbook, a bunch of tasks. We use a bunch of modules on Ansible, and that automates for us to create that database on DigitalOcean. But how we generally do is that we have to separately run this playbook, and when the database is created, then we go run our Kubernetes resources, so our application, our containers to be deployed, and then configure them against each other so that we can create that containerized component of our application as well. But the problem with this approach is that, first of all, we have several different roles that are dealing with different parts of that. For example, the development team or the developer might not really have access to the DigitalOcean account of the entire organization to be able to create VMs there or MySQL instance there. We can see also in this playbook we require some kind of IDs and API tokens from DigitalOcean to be able to run this playbook, and that's something that generally lives with the IT operations. We don't share that widely in the organization because it's a valuable information. We don't want everyone to be able to create a lot of resources in DigitalOcean. Every day virtual machine runs there, it would cost us in essence. So what we can do instead is that what I'm showing you basically is an APB. It's a packaging of that automation broker. This APB, when it's packaged, it's exposed in the platform. If I go in the service catalog in the dev project, as one item in the service catalog, you can see here DigitalOcean MySQL. So me as a developer, when I'm logged in, I don't really need to deal with playbooks. IT operations has created these Ansible playbooks. They're really good at that. Configured it with the correct credentials, so it can talk to DigitalOcean without exposing the API token and other credentials of API token. I can just order them through the interface. So I say I want one MySQL database, and what size database I want. I go with the simplest one for test. Give it a name, so test database. I call this. You can choose which region in DigitalOcean we want to deploy that. Give the database also a name, catalog DB, and also give a password for the admin database. So I just enter a bunch of information, nothing about what is my credential to DigitalOcean or anything like that, because me as a developer do not necessarily have access to that information. Let's click next, and create. So if we look at a project, a provision service is created, and those Ansible playbooks that were packaged as an Ansible playbook bundle, as an APB, is handed over now by Kubernetes to the automation broker in order to run those playbooks and create the database for me on DigitalOcean. So if we go back to DigitalOcean, in a few seconds, you should see that a new database is coming up, and it's Ansible doing those kind of stuff. But me as a developer, I don't need to deal with the playbooks or even know if there are playbooks in the picture. So the value here is that the operations can create those beautiful playbooks that Ansible has to automate every aspect of infrastructure, and we can encapsulate all that within the service catalog in Kubernetes and allow the developer teams to order those services in order to automate deployment of their hybrid application through Jenkins or other type of pipelines without really dealing directly with the playbooks or having to know all the credentials for different services. If I'm combining this with some service on AWS, Azure, and GCP, so there got to be a couple of more credentials that I need to know in order to be able to deploy my service, and the automation broker hides that all away and allow the IT ops to manage a credential and only expose those services as on-demand services to me within Kubernetes. As you can see, the database is created for us automatically, a test database on the Amsterdam region. We already have a MySQL database here, so this was just test to see, and it's running a couple of, it's basically created a VM, and it's still running through installing MySQL automatically through those playbooks on top of the VM. So that's how we can create a database, and we can put that in our pipeline. And in fact, I have created a bunch of pipelines here to show you how that works with the containers. The first pipeline that we have, it's a simple pipeline that builds the application. The source code of our catalog service is available on GitHub. It's a Spring Boot backend service, and the pipeline definition is also within that GitHub. So if I start the catalog build, what it does is that it takes a source code from GitHub, and then we can take a look at the build in Jenkins as well. I prefer the Blue Ocean interface in Jenkins. It has a nicer feel to it. So it takes a source code from GitHub, runs the Maven build, and creates a jar file for that Spring Boot application, archive the jar file, and then build a container image from that automatically in order to deploy it on top of container within the Cool Store Dev project, and use the same MySQL container database that is available. As soon as this is done, we're going to take a look at deploying that in production when we are using the DigitalOcean database. And through the same pipeline, using that automation broker, we can create new instances of database automatically on DigitalOcean, or combine it with other infrastructure services on other public cloud, or on our own on-premise services through VMware or OpenStack or firewalls, and anything that playbooks, essentially Ansible playbooks, can do for us. We can do it immediately through these pipelines, because the automation broker allows us to encapsulate those playbook runtime within the pipeline and expose to our developer without exposing credentials and too much of unnecessary technical details that a developer might not necessarily know or be allowed to access that kind of information. So the pipeline went all successfully, got deployed. If we look at our application, we see that a new deployment number 4, was just deployed. You can see the build was a minute ago, so a new build of the application, the catalog service, just ran, and as soon as that was successful, it immediately deployed a new instance of the catalog inside our development project. So after we're happy with our development phase and everything is run smoothly, we would go to our production project. Let me keep this open so we can look at the production project at the same time as the pipeline. So within the production project, we have the same Cool Store application. Look at it in the production environment, but we are using the database on DigitalOcean. as we looked at instead of the container. So we're combining a virtual machine service with our containers. And now that we have built and are happy with our deployment of the release inside our development environment, we want to promote that build into our production environment. So I'm going to run the deploy to prod pipeline, which we don't rebuild the application. We already have built the images for our catalog service. We just want to promote the same release that we have already tested and we are happy. We know that it works fine into our production environment. So we promote it to the production environment, and we want to go through a canary release in this scenario. We will deploy our container and put only 10% of the traffic on top of the new release. We keep the previous release. We don't want to touch that. See that we have deployed 10% on the new release, and we have paused for approval of release manager to continue with incremental rollout. So if I look in our production, we see that a new release of the catalog service is coming up, and we have only 10% of the traffic on this catalog. We still have the previous release, so if you want to roll back, we can easily just put the traffic back on our previous release, 100%, no changes happened there. But we want to test, for example, with the internal users, or one out of every 10 requests goes to the new release to make sure everything is still working. In this scenario, we're not touching the data, so both releases go toward the same database and use the data, so we have to be cautious of not to corrupt the data between the releases, but we can manage the functionality of the new release for a smaller group of users, so that if there is any problem in that release, we won't affect the majority of our users, and only a small fraction will be affected. Some teams also do smarter kind of releases, so maybe only expose the internal users, the traffic that comes through the internal networks, to the new release. So if you want to test it, we only test our employees with the production data instead of our users. But now that we are happy with the release, we assume that this is working fine, we can continue a rollout and put 50% of the traffic on the new release. So if we look at the traffic divide, now we see that it's 50-50 divided between catalog 2 and catalog 1. And after we have done our test, we are happy with the complete rollout, we can approve to put 100% of traffic on the release. And as you can see, what happens is that we put 100% of traffic on a new release, catalog 2, and remove catalog 1. And some teams might do the canary release in other ways. For example, you still keep catalog 1 or the previous version around if you want to roll back after putting 100% of traffic. So there are different combinations. But the point of this is that we can encapsulate all that complicated logic of rolling out a new release in a very controlled manner, combined with the containers, combined with the virtual machines or function as a service or other infrastructure services or other public cloud services, all within the same pipeline. In this example, we are using a pipeline that is running on OpenShift using Jenkins, using the declarative syntax that we have in Jenkins. The pipeline is also available within the source repo. You can take a look at it there. And have an end-to-end automation of the entire hybrid application, regardless of what type of components that are involved in it, which is extremely powerful. It helps us not to have this disconnected flows of automation for Ansible separately, for Kubernetes separately, and for other infrastructure separately, and combine all of that in an end-to-end automation pipeline, and help us do quite advanced and complex deployment scenarios that cross over all the services that we have. If I look at the dev, so we have the database deployed. Every aspect of this database is automated now through those playbooks that are running in the automation broker through the automation broker in Kubernetes. So if I delete this service now, that is also would be replicated or communicated to DigitalOcean through the automation broker and through the playbooks that are running within that Ansible playbook bundle. If you take a look at DigitalOcean, the database is automatically removed. And all of that without me as a developer to need to access any part of DigitalOcean per se. So I could just manage all that functionality within within the Kubernetes where I have access to within my own project. A question that comes up is that, all right, so you create a database, but how do you, as a developer that doesn't have access to DigitalOcean necessarily, know the credentials for this database, what port and what IP that database is deployed so they can use it in the application? So that is also something that is automated as a part of the Open Service Broker API. So when you provision a service, that all the credentials that are required for consuming that service, it doesn't matter what kind of service that is. Right here, MySQL database is just an example. It could be any other service, could be a queue running on SQS on Amazon, and you still need some credentials for talking to it through the applications, not necessarily the AWS credentials, but just for the queue itself, and where the queue is, the location of it, the coordinates of that. And all of that is automated through that standard. So when I instantiate a service through the Open Service Broker API, a secret object is created within Kubernetes. Secret object is a Kubernetes object that contains sensitive data. In this case, the MySQL data. So it exposes the database name, the password that was generated, and the host for it, where I can talk to this database, and I can use this information to within my application to connect to that. And how do I get access to this information? Within that pipeline, we have automated that as soon as this secret object is created in the project, this information gets injected as environment variables within the application, and the application can use them as environment variables to configure different aspects of that. So here you can see that we are mapping that secret object within the container that is running our service. So if I take a look on the container, with the OpenShift allows you to access, have a remote shell directly within the web console inside the container. So I can run an fn command and grab APB. You can see all that information is injected into the container automatically after the service is created. So we have an end-to-end scenario of, through the service catalog, we provision a service, or maybe through our pipeline, provision a service via the service catalog. That service might be provisioned on OpenShift or on Kubernetes or on VMware or on AWS or open a firewall or whatever that happens. And a credential object, a secret object, is created automatically in Kubernetes that holds the information of how to talk to that service, and that information is automatically injected into the application to be able to talk to that service that was just provisioned through the pipeline via the service catalog. So we have an end-to-end automation here that we can instantiate service and automatically know inside our application how to talk to our service that is living outside the platform. And with that, I conclude today's session about applying DevOps principles to hybrid applications. So the takeaway today is that using the automation broker allows us to combine Ansible, which is a really powerful tool for infrastructure automation, with Kubernetes, which is a very powerful tool for automating container deployment and container management, and bring all of that in an on-demand way, self-service manner to our developer teams, and to be able to build pipelines that use that to have an end-to-end automation of our hybrid applications. Thank you.
Well, that's all the time we have for today's webinar. I'd like to thank our panelists for joining me today, and I'd also like to thank the audience for attending. Just a reminder that today's event has been recorded, so if you missed any or all of it, you'll be receiving a link via email post-event that will take you right to the webinar. The webinar is also going to be living on the DevOps.com website. If you want to access it there, just go to the Webinars tab, click On Demand, and you should be able to find it right there. We also have a list of other on-demand webinars and upcoming webinars. So while you're there, just take a look around. Hopefully there'll be one or two that pique your interest. Again, I'd like to thank you for joining me, and I'm Charlene O'Hanlon, signing off. Have a great day, everybody.